go. Computer. Perfect. All right, everyone. Now we have officially started. So welcome to lecture number 9, unit testing. Again, it has been so long for people who just joined. I have missed you all. Welcome. I mean, I guess I'm being the one coming back. You all were waiting for me. So thank you for taking me back with open arms. If they were open, whatever. Let's get into this thing today. Just a quick thing too, there might be a little bit of background noise. I apologize. This house is a community house, but I am a quiet little section over there, so we shouldn't have any interruptions, but I apologize for what you might hear. All right, let's talk about announcements. Let's dig into it. The first thing is, you probably already know this, assignment number 2 is due today. It is not a drop assignment though, so that is a good thing. So if you are still working on assignment 2, that's completely fine. However, remember, you do not want to fall behind. So what you want to do is make sure that you are reaching out to your colleagues, your TAs, your TFs, myself included, to get that assignment number 2 done. A big thing is that every assignment builds upon each other. So you must be able to get assignment number 2 done before you get into assignment number 3. Otherwise, you're just getting disheveled and there's a lot of things falling on you. So highly recommend getting that assignment 2 done as soon as possible. All right. We're going to keep moving on here. So the next thing is that tonight you're going to have a guest studio reviewer. As you all know, our guest lecturer last week was Bree. She got to teach all of lecture, but she did not get to teach the studio. So tonight I promised that she can do that. So she will be taking over that. For whatever reason, if you have any questions, let me know. But yeah, after that, feel free to come back into lecture. She'll be going through that studio review with you all. It's going to be a fun one too. All right, and then the final thing here tonight, make sure you all are paying very close attention to this. Assignment number 2 is done, but assignment number 3 is coming right down the street. So assignment number 3 is going to have a lot of this unit testing stuff we haven't really gone over inside of it. And I've seen in the history, this assignment number 3 can be slightly more of a biggie than the others. So please make sure you are paying attention tonight and everything like that. So basically assignment number 3 does not come to a surprise. So awesome. Any questions about that before we get started? Anything at all? Anything at all? All right. Well, I just hear silence. So let's get people talking then. If I wanted to build an object called cake with property of name set to chocolate cake and a price of $10.99, because that's how much chocolate cake is nowadays, dang inflation, how would I do it?
Cake. And
I'm missing one thing before that. We are declaring something. Const or let, I will take either. But yes, we always got to make sure we have that when we're creating that new variable. Very good. Let, and then I heard cake. Awesome. Then what comes next?
Curly brackets.
Curly brackets, because we're building an object. Very good. Absolutely right. And then help me out. Let's start out with name. What do we do?
Name.
Very good. Name. Colon. Absolutely. And then?
Chocolate cake.
Chocolate cake in those double quotes because it is a string. Absolutely right. Awesome. And then, of course, the comma. Very good. I heard that in there. And then finally, talk me through this last one.
Price.
Very good. Price.
Colon.
And then $10.99 right there. Awesome. But no quotes around it because it's not a string. It is a number. We can also include decimals like that too. Numbers, no matter if they're integers, whole numbers, or decimals, we include them just like that. Very good. But let's go ahead and dig a little bit more into this. If I wanted to change chocolate cake to birthday cake, we've declared our variable up there, cake. How would we utilize this variable to change our value inside of this object?
Cake dot name.
Very good.
Equal.
And I think I heard it. Yes, equals birthday cake. Very good. And just like this, we can change those properties inside of that object using dot notation. Now, bonus points. What's the other notation we can do to do this task?
Bracket.
Very good. Bracket notation. Absolutely. We can say cake, open square bracket, name, because that's the property or the key of the property that we want to change, equal to birthday cake, the new value we want to set that key for that property to. So any questions on this? Didn't think so. You all know this. Let's keep digging a little bit deeper then. How would I start building a function called bake that cake? By the way, it is a cake theme today. Bake that cake that takes in the name of a cake and a price as a parameter. What word do we start with?
Function.
Very good. Function. We're creating our own function. Absolutely. And then what comes next?
Bake that
Bake
cake,
that cake.
parentheses at the end.
I just love hearing that. Yes, absolutely. Bake that cake. And we include our parameters in there. So cake name and cake price. But my fun question to you all is, how would we return a cake object with the name and price inside of it? What word would we start with in order to do this? Let's tackle that first.
Structure.
We
Return.
would do return. Very good. Return. Now, if I wanted to build an object, what would I use?
Let.
Curly bracket.
Curly brackets. Remember, let is to create a variable that can contain whatever, including an object. But to create an object itself, we start with those curly brackets. And then in order to set the properties inside of this object, we always have to start with the property name or the key, in this case, name. One more thing we want to do, we want to set that cake, or the name of the cake, to whatever's passed in as the parameter. So in that case, we would include the parameter name there inside of this object. Now help me out now. How would we do for price? What would we do for price?
First you need a comma.
Comma.
Oh, tell me one more time. What was on the left-hand side? What name?
Comma.
Oh, of course, a comma. I'm sorry, I apologize. Okay, pretend a comma's in there. I can't press a space bar because then it shows the answer. We have a comma in there. Then what comes next?
Price.
Very
Price.
good. Price,
Colon.
colon, and then
Cake price.
Price.
cake price. There we
price.
go. Awesome. I wish I like chopped that up a little bit more, but we get what we get. Yes, price, colon, cake price. Right here is how we can return an object without having to create it into a variable and then returning it. But you might have seen this in some of your work or your prep work for unit testing. There were some things there. So I just want to go into a little bit more explanation about what you might have seen. So here's how we can just return an object right away from there. And this is also a very sneaky way kind of to return more than one thing. Remember, you can only return one thing, but that one thing can be a container of data, aka an object or an array. So if you ever want to return more than one thing for whatever reason, this might be one way you could explore to do. All right. Y'all ready to continue? Let's keep doing it. This is going into the week that I didn't get to see you. If I would allow this function to be shared with other files and applications, how would I do that?
Module.exports.
Very good. Module.exports. And then what do?
Bake that cake.
Bake that cake.
Equals bake that cake, the function name that you want to export. In this case, we only have one function, so this works fine. Remember, you can always use those curly brackets as well and build multiple kinds of exports that you saw in the previous chapter. So awesome. Now, one more thing I want to talk about here is that this is great to export things, but as you might have already learned with modules, again, in our last lecture, is that we want to include these all within its own file. You typically don't want to be exporting anything from your index.js, that one file that we see in Replit all the time that we start with. Instead, we want to create our own file with all these functions we can share throughout our application. So in this case, I would call this bakery.js because it's baking the cakes. So that's one thing I do want to call out about imports is make sure you're containing these things in their own files, not the index.js, something else that's actually named that truly calls out what these functions do. So any questions about that? So what we're going to do real quick is we're going to go over to Replit. If I have Replit open, I do not. I'm going to go and open up another lecture 9 here, and we're going to go and build this real quick so we have this to work with during this lecture. As I'm doing this, any questions about anything that we just covered? All right, then we're going to go and just do this. As always, we're going to do this lecture. I'm sorry I didn't have this up before. There we go. Loading those files, and that's what we want to do. What I'm going to do over here on the left-hand side of Replit, I'm going to go and click this plus, this add file. Down here, we called it the bakery.js. That's what we're going to do there. We're going to let Replit catch up. Perfect. And now we're going to go and build our function. We're going to say function, and then we said what? Bake that cake. Oops, I'm doing that. And we're going to take in two parameters, the cake name and the cake price. Very good. There we go. And then we are going to return that object, that new cake object. So how we do that, again, help me out with the one we didn't do together. I want to return the cake name first. What do I type here?
Name.
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 Very good. Just name, colon, and again, that variable or that parameter we're passing into the function. So cake name. And because I'm nice, I'll do the next one for us. Price here, if I can spell price right, and then cake price. Awesome. Just like that, we have successfully created our function. The last thing we need to do is create the export. So we say module.export equals bake that cake. Awesome.
It says exports. Should it say export?
Is it export? I honestly get the plural one always mixed up. So is it export?
I think it's export.
Export.
Yes.
Singular or plural? I'm here. I can barely hear the plural. Okay, I
Plural.
thought it was plural. I was trying this out. I was like, let's forget what the module is exports. All right, awesome. So there we go. We have successfully created our stuff. Let me go ahead and just.
Hi there. I'm sorry. Which
There we go. All right. So we are exporting now this function. So anything about this? Any questions at all? All right. Let's go ahead and run this just to make sure that we are all good here. What we're going to say is const bakery. And we're going to say equals require, and we're going to import that bakery. So it's going to be ./bakery.js, perfect.js, just for good measure. Perfect. And then we come down here, and in order to run it, we say bakery, open and close parentheses, because we're just exporting one function right now. We don't do that dot notation. That's the difference between those curly brackets and just doing the equals bake that cake. So we call it absolutely directly. So let's go ahead and run here after a second. Someone give me a cake name. Who's got a favorite cake? Anybody? Strong opinion?
German chocolate. Chocolate.
Cherry
I
chocolate.
was gonna say German
Cherry-
chocolate too, yeah.
Oh my gosh, don't give me
Chocolate gooey
too many
butter.
words to write here. I'm going with cherry chocolate. I'm always afraid of giving like, okay, help me out here. Please don't give me too many hard words to spell. I told you all that in confidence. I cannot spell. I'm gonna say $10.99 for this one too for the price. Well, let's go ahead and run this. Oh, we're not gonna see anything, are we? Because we need to actually see what's returned. So what I'm gonna say is const cake equals, remember that object is gonna be returned from the function. So this const cake variable is gonna be assigned that object. Once we do that, we wanna see it with human eyes. So we say console.log of cake, just like that. We go ahead and run this. And there we go. We have a beautiful cake object. Fantastic. All right. That was some fun stuff right there. Anything else that we want to talk about what we just covered here before we start digging into some new stuff?
I have a quick question.
Yeah. What's up?
The parentheses after require, why is it only one dot again and not two?
Remember, 2 is taking us back a directory. Takes us back a directory. Single dot keeps us right in that directory. Index is in the same directory as bakery. 1 dot. If it was a
Okay.
file back, we do 2 dots.
Okay. I didn't realize they were in the same one. Okay.
Yep.
So I have a quick question, Kyle. For line 3, the cake,
Yep.
was that a random variable or was cake assigned in the other one? I can't remember. Like, did you just
Remember, any variables in this context is absolutely up to you. Up to your creativity. So are we talking about this cake variable right here? Or are you talking, I'm sorry, I might have talked a little bit too fast there. Are you talking about the naming of the variable cake or the data inside of it?
Yeah, because you're pulling from that other, you're pulling from the other file. So I guess I couldn't remember the name of, yeah, so it was bake that cake. So how do we
So
get
remember
to
here, when we're setting it to this, we only are setting it to one function. So this module.export is just one function. So it's actually up to whatever I name it up here, bakery. That is how we call the function. Because again, when you create variables, it's up to your creativity. So
Okay.
to help out with that, what we could say is that up here, if we didn't want that confusion, we could say bake that cake. Like that. And that would cut down maybe on a little bit of confusion. Another way, typically, too, that we saw in modules is that we would assign it to an object by those curly brackets, like that. So this is allowing us to do multiple functions on an export. So if we did this, what we'd say is that, okay, we're going to name this back to bakery, because we don't want to call it that function name because that'd be weird. B-A-K-E-R-Y. So that's the bakery. And we'd say bakery dot bake that cake. So there's 2 ways to really export. I don't typically recommend doing just the equals there because you can only do one function. This way, when we assign it to these curly brackets, we're able to export multiple functions. So this bakery just can't like create cake. It can create, I don't know anything else better than cake, but it can create more things. So that's why the curly bracket approach is typically more recommended. but we just did this for kind of more time's sake. Does that kind of help out? That was a long-winded answer to that. I apologize.
Yeah, that really did. Thank you.
Yeah, absolutely. All right. So we're going to keep on going here. In order to keep everything consistent, I'm going to go back to what we just did there. Perfect. Space. Come back down here to index.js. And we'll take away that. Awesome. All right, everyone. Let's keep on going. Does this every time on my ear. Give me 1 second. Come on, buddy. There we go. All right. So today we just created that bakery. That's awesome. We have been creating code since we started this class. You know how to create functions. You know how to do everything within functions, do the conditionals, all that fun stuff. What you are doing is creating new technology. Now, you might see it as whatever, just the beginning steps of it. That's great, but you are still able to create new things. And that's awesome. But remember, out here in the real world, when you are coming out here and you're creating those applications for yourself, or even in class itself, we are still to the core human. We are creating new technologies, but we have to deal with our human element. And unfortunately, the truth to that is that we all make mistakes. I myself make mistakes every day. Like I always say, I use pencil, and I honestly religiously use pencil because I make so many mistakes a day. So we all will do this. And in coding, you've already seen logical errors are not only the most sneaky, but the hardest ones to actually debug. What is actually going on and why is my logic not working properly? So when that happens in any developer sense, because again, all developers are human for right now until the AI overlords take over, we will make mistakes as developers. And those mistakes are extremely risky. Not only risky to the technology itself, but to the bottom line of the company, and maybe your manager will start to notice if we start to make a lot of mistakes. In essence, healthcare. If you are working or you are relying on certain technology in healthcare, you want to make sure it works. In aircrafts and financial systems, every major thing that runs our life is built usually with code. And those codes are, again, developed by humans that can make mistakes. We as developers need to know that one, we will make these mistakes, and two, make sure we are preparing for them. So it is our job as developers, as we get into this kind of area of things, is to police ourselves, to make sure we are not making those mistakes. Because again, they are risky for everyone. Yourself having a bad Monday when you realize something is broken, to your user coming back and saying that something has absolutely happened, something catastrophic. Because of these situations, we need to explore how to exactly police our mistakes. We need something to double check us. Now, if you look at your computer and we'll realize, why is my computer not working? It's, again, not because the computer is messed up. It's because that there's something wrong logically, possibly, with our code. So that being said, we want our computer to be able to check us. So we need to make something in order to have our computer check us whenever we're done and make sure our code is still what we expect it to do, or do what it's expected to do. This long-winded thing about we are human, whatever, is leading us to what can we do to police ourselves or to keep us from doing all of these bad typings and having that bad Monday. The thing that we use is called unit testing. We need to test ourselves. Make sure our code integrity is up to the proper standard, no matter what that might be in whatever environment you're in. In JavaScript specifically, today we'll be introduced to the technology that will help us. Her name is Jasmine. She will be the one causing absolute headaches in all of our heads as we move forward with unit testing. This is an open source testing framework for JavaScript specifically, in order to test our code, which we'll go into a little bit here in depth in the near future. Real quick, I want to talk to everyone quickly about open source. If you're wondering what open source is, I know that's a big buzzword. That just means that this is a free technology out there to use, that you can look at the source code and they don't hide it from you or anything like that. It's not proprietary information. They'll actually show you what Jasmine's truly doing, which is a great thing. It's just a huge perk of the development community is open source. Always got to be careful about what you use. Make sure you read the reviews, but open source is a beautiful thing. All right. So yes, Jasmine is what Jasmine is what we are going to be using in order to test our stuff. But the question is, who exactly is Jasmine, and how do we how to exactly use her. So let's go ahead and take a look at that real quick. You'll see a lot of, as you get further into it with more testing stuff, you'll see things like this. I just took this from one of our previous replets, or the replet you're gonna be using tonight, or even the exercise one, you might have seen this already. And I just wanna go through it real quick. I'm gonna be copying and pasting this if I ever use it in an example, because I don't wanna type all of this out. But we're gonna go really quick through what exactly this all is. If you have opened up any of the previous exercises, or sorry, any of the exercises for this, or even the studio, or even look through the example code, you will see this, Jasmine's starter code in the index.js. First things first, do not touch this. Do not try to touch this. What is written here is perfect. It will work every time. Do not try to edit it. It will cause more headaches than it will fix. So Jasmine, of course, you know this line. We are requiring Jasmine to come into our project. We're going to take Jasmine in. Down here, we're going to declare Jasmine to do something. This is basically creating an instance, so we're going to call it, of Jasmine to run. And down here, it's basically just going to tell us, okay, I want you to run these files, these testing files, in a thing called spec, in the spec directory, dir. That's the important thing right there, the spec directory. All tests are kept in the spec directory. Spec is short for specifications, basically the guidelines of what you want your code to do, and the test in there to prove that the code can actually do that. So spec is short for specification. In here, you'll typically find some of these fun things. So what I'm gonna do up here is gonna copy our index.js for the Jasmine stuff. We're gonna copy that, bring it over to our lecture here. Goodbye, Bakery. It's been nice knowing you. And we're gonna bring in Jasmine there. The next thing I wanna do is I'm going to create my spec folder. You're not gonna typically have to do this. Launch code will typically help you out with this. Most IDEs will typically help you out with this, but it doesn't hurt to see this through and through real quick. So what I'm gonna do, once I pasted that in there, I'm gonna press add new folder and call it spec. Again, all of my tests should always be in the spec folder. And then in here, I'm going to add a file. I right-clicked, press add file, and what I'm gonna call this is bakery.spec.js. We put spec in there because it's telling us it's a testing file. We also include the word of the file it's testing, aka bakery. So there we go. Our bakery spec.js is now created. Awesome. So we now have been introduced to Jasmine. We know kind of what spec is, but we keep talking about these tests. We haven't really seen anything about the tests. So I'm gonna pause right here, ask any questions that everyone has any questions about Jasmine before we start actually seeing what these tests even are, what they're actually doing. Anything at all. Oh, and I am not allowing you all to unmute. All right, any questions?
I know you just explained this, but on the index.js, could you go through what line 4 means again?
Line 4. Line 4 means Jasmine.load configuration.
Oh,
so basically
well,
you're telling.
no, on this one it's a different line, line 2.
Line 2 on this one. This is creating a new instance of Jasmine. We haven't really gone into what this keyword new is. So just think of it as it creates Jasmine herself right there, ready to test. Basically just saying, hey, Jasmine, get over here. So that's kind of what line 2 is doing. It's creating a new instance of the Jasmine class, if you really want to know. But we won't dive too much into it because we have not discussed any of that, but that's essentially what it's doing.
Before we leave that page, we know it's kind of been hammered home to us not to use var, but this called var. Is that
right? So for when we are actually practicing JavaScript, no, you will not want to use var. In this case, this is just boilerplate code, which just means very repetitive code. So don't worry about it. Don't look at that var as like proper practice. But no, you will typically be using less, or you will always be using less than const. Just don't pay attention to the var.
okay?
So I've seen var be used in many examples of code online. Like, what does it do? Like, what does it mean?
I'll offer a very, very quick explanation. So there have been many versions of JavaScript. var comes from a predecessor of the current version. ES5 and ES6 use let and const. That is the newest.
Okay.
var is the old thing. So it's basically asking, do you want to use a tube TV to do your coding, or do you want a flat screen TV? Typically, we want to go with the nice flat screen TV, so use your lets and consts.
Okay, thank you.
Absolutely.
And Kyle,
all right, everyone.
And
yes.
Kyle, on the line number 2, it could be any name, right? The Jasmine, the one starting with the small letter Jasmine.
Absolutely. As we always know, that we name our variables whatever we want, as long as we call them properly throughout our code. Yes, this is always up to your creativity right here.
But then the second one should be exactly like that with the capital Jasmine.
As all, yep, absolutely. Got to keep all of your variables exactly the same. Absolutely. All right, everyone, let's keep going. We've got Jasmine in here, but we want to get to the fun stuff. Let's see testing in action. Awesome. There we go. All right. So, congratulations. You all have made it. You are now the test writer. If you ever thought back in grade school or high school, you're like, I wish I was able to write the test. I do that way better than they did. Congratulations. You've graduated. You get to write the test. Let's see how we actually do that. We're going to be writing our tests in this framework, Jasmine here. Oh, and real quick before I'm going to pause, I apologize. I didn't see that. How would module export look from outside spec and any spec? You're not going to typically do a module export at all in spec files. Those are just for tests. Remember, module.export is when you want to reuse code or functions elsewhere in your applications. Tests, we are not going to do that. Tests are only there to make sure your code is working. All right, and then I see, just to make sure Jasmine is present NPM for testing the code functions, correct? I apologize, make sure that question is correct. If you're asking if Jasmine is just present in order to test our functions and our code, yes, it absolutely is. All right, so like we said, we are in Jasmine. Jasmine is going to be running a bunch of tests, but she needs something to actually run. So she requires a couple different keywords and a couple different ways in order to do this. And the first one I want to introduce you all to is the describe keyword here. Describe is going to be a very, very powerful keyword. And then after that is a little different. We're going to include a parentheses and then some text inside of there, and then comma, function, and then close that curly bracket in parentheses. Now hold on, I know this is a lot here and this looks very weird, but I want to go through it piece by piece. Let's first start with describe and what it even is. Describe is the keyword that we're telling Jasmine, hey, we're about to test a bunch of stuff. I want to provide you some context. What I'm about to test. Now think of it if you're testing out an automobile because you work for GM or whatever. You have many parts of the car you need to test. You have the driving, you have whatever, the air conditioning. I'm terrible at cars, but all the things that make cars do their thing. But what you should really think of is that you have many different sections of an automobile to test. Describe is basically providing something in order to tell them what section you're testing, what context, what are you doing? In this case, I'm testing the bakery, or I'm testing to see if the bakery actually creates the cake, other than maybe cookies or something like that. So again, describe helps us offer context into what we're about to test. After that, like I said, the string next in there is the context you're going to provide. What are you testing? And then, as you all know, the next thing is that anonymous function. In here goes some more fun stuff. So let's talk about that. Inside that function, once we say what we're going to be testing, it's time to actually do what we've been saying, test something or write one of those tests. To do that, we use the next keyword, that keyword being it, IT. You're about to test it. After that, just like the describe, we include a parentheses there. And then with that context in there, what is this test going to do? We basically phrase it as, it should do this. Hence the keyword it. It should return a cake object. Because remember, bake that cake is returning that cake object. And then we say another anonymous function. This is what's going to run afterwards. And then we include that stuff inside of there. So again, let's run through that. To start writing a test that actually runs and checks something, we use the keyword it. This will contain the actual test. Then after that, inside of that it statement is where we're actually going to include what we're going to be testing, which we'll be diving here to in a moment. Raiden, I guess you can technically think of it as a function, yes. They are keywords also. You cannot use describe as a variable name, so that's why they are referred to as keywords. They are reserved words if you want to get technical. But yes, because we provide actually some arguments inside there, then yes, technically it is, you can think of it as a function. All right, so awesome. We know how to write our test. Let's go ahead and start doing that. We're going to come over here to our bakery.spec.js. Remember, our spec files are just for our tests. In order to start doing everything, what we're going to say is describe. I'm going to have to bring over one extra thing here. There we go. I'll do it in a second. Where am I at? There we go. Describe, and what we're going to do is say we're going to test the bakery. Testing the bakery. Perfect. And then we include that anonymous function. Just like that. There we go. All right, now over to all of you. What comes next? How do we actually start writing an area for our test? What keyword do we start with?
It.
Very good. It, and then what comes after that?
The parentheses.
Very good, parentheses. And then what goes inside those parentheses? The first thing.
String or quotation marks.
String, but what's the string do?
Explaining what you're testing for in that particular line.
Very good. And how do we explain it? What is the typical word we start with?
Should.
Should. It should. And then return a cake object. Yes, I need to put my quotes there. There we go. And then what is the next argument here that we need for it?
Anonymous function.
Another anonymous function. Absolutely right. Oh, those things are just getting more and more intense, aren't they? So you might be seeing me put these semicolons at the end. This is just for my coding OCD here, because I do have to do this in my typical day job with this. So you can put the semicolons there. It's good practice, but you don't have to, and you might not see it in some examples. So just letting you all know. Very good. Awesome. We have written the start of our first test. Let's go ahead and run this and see what happens. It's going to install Jasmine in there. And what we're going to see here is that it comes over here. It says randomized with seed, whatever, 35777. Don't even worry about that. And then we say started. It says 1 spec, 0 failures. And you'll see a little green dot here. That means everything ran. All of our tests passed. That's awesome because we're not testing anything. So that's why we see that green dot. So I'm going to pause here. Any questions on the it or describe before we keep on going into the good stuff? All right. Then let's keep going here. So we have written the area for all of our stuff in order to check to see if our stuff is working. So let's see how we can actually write this. Now, what this it statement says here is that we should return a cake object. So that means inside of this it statement, I need to check that. I need to test that. I need to see if I run bake that cake, it gives me back exactly what I'm looking for. So that's what we're going to write here. Let's actually check to see if our function is doing what it says it's doing. First things first, as we saw before, we need to bring in the bakery. We need to bring in those functions. So we exported it and we can import into the spec files. We will always be importing into the spec files. Again, we won't be exporting. So up here is what I'm going to do. So I'm going to write bakery const bakery equals require, and then dot slash bakery. Again, we did a dot slash because bakery.spec.js is one file up from bakery.js, aka it's in the spec directory. So in order to back out of a directory, we do 2 dots, dot, say, hey, go out of this spec folder and look then for bakery. So again, those 2 dots means go back a directory, so out of the spec directory and look for bakery.js. So that's what that means right there. So awesome, we are importing bakery. Oh, and I just saw the question there, why do we need 2 anonymous functions? Great question. Remember, this anonymous function belongs to the describe. So this one right here, because describe is containing a bunch of tests of a certain context, meaning what are you testing? And then the it one also needs it to run. Think of this as in this describe function needs an engine to run. So we have to provide it that anonymous function. This it statement here also needs an engine to run. They're completely independent. So we need to provide it an anonymous function to run as well. Hence why we have 2 of them there. Awesome. All right, let's keep going. So we have all this doing, we're passing our test, but it's actually not testing anything. So this pass doesn't, technically it's a false positive, or it's just not helpful. So let's make it helpful. All right, this is where we start getting into the meat and potatoes. Let's start by getting our information back to actually check. How we start getting the information back to check, we need to create a variable. So I'm going to create the variable const actual equals. Now this name was picked very, very, very specifically for a reason, and let's dive into that. In tests, two things, or in those if statements, the actual test, again, meat and potatoes, two things are very important. The first thing is your actual. Actual means what the function is actually returning, what reality is, what is truly happening with your code. That's like, okay, it's like, unfortunately, it might be good, it might be bad, but whatever it is, it's what actually is returned. Specifically what is, yeah, I can't think of a, wow, really can't think of a synonym for actual right now. But you get the point. What's actually coming back from the function. The second thing, there we go, second thing that a test requires is what is expected. What you truly want your actual to be, your hopes and dreams. I really hope this function returns a proper cake object. But our expected should be what we want it to be. So essentially our actual is like, okay, here's what's truly coming back in reality. And your expected is like, I hope it's this. And those two pieces are what we need to actually write tests. All right, so awesome, awesome. So now that we know the differences between our actual and our expected, let's go back to our code here. Const actual equals. Remember, actual is what's actually coming back from the function. So in that case, our actual should be equal to bakery with birthday cake in there and 10.99. So we run the bakery, aka the bake that cake function. Again, that's how we exported it. If we remember from previously in this lecture. So we're exporting it. So we pass those two arguments inside of there and we get back our actual data. The next thing is our expected. Now ask yourself right now, what do we feel like our expected would be? Would it be a string? Would it be a number? Or would it be that object that should be returned from this function? So the object, you're absolutely correct. Our expected should be the exact object that should be returned from that function. Now, if you're asking yourself, isn't this a duplication of data? Yeah, it absolutely is, but we need those two pieces of data to check against each other. So our actual, again, is what comes back from bake that cake or the bakery function that we're running there. And then we need to match it up against something that's hard-coded, aka directly written out that we see here on this line to check against it. Think of yourself as taking a test. You're gonna mark your test like to the best of your abilities. In my case, my worst abilities was English class. If you try to mark out that thing, you need to give it to your teacher to check against the answer sheet. You turning in that test was your actual. The teacher with the answer key is the expected. Those two things need to match up in order to see what the true result of the test is. So again, those are our two pieces of information. Now comes that one part. Like we just said in our analogy with the English class, we just turned in our English test, and now the teacher's gonna check it. We need to actually grade our English test. We need to grade our test here. And what we do is use the keyword expect. Expect. This is going to say, okay, I want this thing to be that thing. AKA, I want to expect my actual value, that variable above, to equal my expected. So there we go. We can now grade our test here. So this is going to check the results. So let's go ahead and see that in action real quick. So const actual equals. And then again, we need to actually call out to the function. Function is bakery. And then we include, I think I said birthday cake, and then 10.99. All right, you all have been too quiet. So let's go ahead. What comes next? What is the next thing I need to declare here?
Const expected.
Expected,
Const expected, but tell me this, what is expected to you? What is expected?
Object.
It is going to be the object, but what is the true meaning of expected again?
What you want it to look like.
Is what we hope.
Yeah.
Exactly. It's what we want it to be.
It would be name, birthday cake, price, $10.99.
Very good. And price is $10.99. And that's awesome. I'm going to close this up just a little bit over here. And then finally, after we have our actual and expected, the last thing we need to do is grade our test. And what keyword again, or not keyword in this case, what function are we gonna be using in order to do that?
Expect
Expect.
actual.
Very good, expect. Very good, everyone. We're gonna type in our actual first. So we expect our actual to
To
equal,
equal.
and then our expected. Awesome. All right, let's go and run this and see what happens. Oh no, what did I do? Oh, come on, buddy, really? Right now?
It's Barkery.
It's Repl being Repl. It's a Monday. Gotta give it a break.
It says
And on the line
Yeah,
one,
yeah,
it is
line-
You
Barkery.
misspelled bakery.
It's spelled-
Oh,
Yes, ma'am.
Barkery. Got dogs on the head. Thank you. Oh my gosh. Thank you. Thank you. There we go. Awesome. We have 1 spec and 0 failures. Fantastic. But the one thing I like to see, okay, so it ran. That's awesome. But let's actually see it fail. How I want to see it fail is I'm going to change this over here to chocolate cake. Chocolate cake. There we go. So now it's going to return chocolate cake in its object instead of birthday cake. So we run this. We see we get a big fat F over here. We failed our English exam. I'm sorry. So that's one big thing to check is that make sure that when you're writing your test, it passes, but also check the negative of it. Does it fail if I think it's going to fail if I change this one thing? This truly checks the integrity of your code. So that's what we just did there. All right, everyone. So that right there is our first test we've written with Jasmine in JavaScript, and we learned like a bunch of new keywords. Any questions on that?
How will we understand in which file we have mistake? Like sometimes when we write this code, we will have mistake, or in the file which we have the function. So
what you're going to see is exactly why describe is there. If you see our failure right here, it says testing the bakery should return a cake object. When you do that, you should remember which describe says testing the bakery. Well, if I do a search on that, it says testing the bakery right there. And then, okay, which test actually failed? Well, which one has the context of should return a cake object? Well, if we look down here, that context is right there. So that's why we provide the describes and the its. It really helps us navigate in our test where it is failing. So to get down to the particular which file you're in, if you really want to get into it, is right down here. We see bakery.spec.js at line 7. So that's another way you can do it. You can actually look for that file name as well.
Okay.
Awesome. Any other questions on that? All right. Can we have 2 describes in one file to test 2 different functions? Absolutely. You can have as many describes as you want. If you wanted to, you can just copy this guy right here. If my mouse, I forgot my mouse at home. Oh, it's gonna be terrible. We can have 2 describes in here for sure, but make sure you have to need 2 describes. Are you testing 2 different things? Are you testing the air conditioning and in the wheels of your car? Are you testing 2 different things in your bakery? That's what describes are there for, to separate or give separation between your tests. Now inside the describe too, and we're going to explore this a little bit more here in the near future, is that we can also include many its inside of describes. And that's how we write multiple tests within the describe. So yes, you can definitely include multiple describes within one spec file. Not a problem. Just make sure there's justification for it. There's some difference between how, there's some difference between how 2 equal and the triple equals would compare things, right? Well, remember in how we're doing this right here, the 2 equals, we're comparing, actually, let's see. Well, that's not gonna be that. The triple equals what you're gonna do in a conditional. We are running the 2 equal function here. I forgot exactly if the 2 equal does the strict equals on it right off the top of my head.
I think it does it should be doing a deep comparison. That's why you can do it, compare with 2, you can find a match between 2 objects.
I would be very hesitant to say that it does a deep equals on a 2 equals. That's typically not the case. 2 equals will not do deep comparisons. They will do a reference comparison, which actually just answered my question. If it does have 2 objects, it will compare the 2 objects at the same reference point, but that does not always include, If it has two references, they're obviously equal. But if you have two objects that have different references with the same contents in them, the two equals will say that they are dissimilar. So do not use two equal for any deep comparisons.
Well, how does it? How would these, if you these actual and expect, how would they end up with the same reference?
Because of how JavaScript does reference memory. So basically, it will allocate a pointer to the same value. So if the one string is the same exact like contents, it won't have two strings with the same exact value. Again, this is take it with a grain of salt. But if it has the same value, it will use that same pointer, or sorry, it will point to the same reference point, and that's what it's really doing the comparison on. We can dive this a little bit more into it, Raiden, if you want to, but the bottom line is do not use two equals for a deep comparison. It's extremely risky and very dangerous and typically doesn't work. All right, so this is how we can write our test. So any final questions about the expect, our actual and expected? All right, then let's keep going. I want to talk about one more thing tonight before we send y'all off. All right, so we got our bakery baking. That's awesome. But just like in typical ingredients with a cake and everything in general, we as developers will be given a giant list of things to develop for our users or our bosses or whatever. In the greatest British baking show of cake that I have actually never watched, only a few clips, it is really good. I can't bake at all, but it's a great thing to watch. They are given many requirements for their food items, for their cakes. In this kind of British baking show, just Kyle's British baking show, or Kyle's American baking show, or whatever, we are going to talk about how we could typically build a cake here in just general reality. Say maybe it must have confetti inside. The chocolate frosting must be on the outside, and it has to have a nice birthday message on top because we're creating a birthday cake here. Now take a look at these specifications. Look at how they're laid out. Again, we are always going to be presented with a list of to-dos as developers, what our application actually has to manage to do. It has to basically make some kind of task a lot easier. And we're going to have specifications in order to do that. But again, look at this. Can you do one of these things before the other? Look at the must have confetti inside. Can you check to see if a birthday message is on top of it before we check if the confetti's inside? No, because if there's no confetti inside, the cake has been baked or it's been baked wrong, so we don't even need to check the other requirements. So once the cake is baked, then we can put frosting on it. Let's go ahead and check to see if it has chocolate frosting on it. Again, we have to do this step by step here. We can't check again if we have the birthday message on there before because the frosting has to be down first. And then finally, we check to see if the message is on top of the cake. Kind of like what they do at any major grocer, kind of just write the happy birthday and then the person's name on top of it. But essentially what we're doing is building a cake from the inside to the outside and checking to see if that cake has been created properly. So again, from this analogy, take away that each of these specifications has to be checked step by step. Step by step. That is a big thing. And it's the same thing with coding. We're going to be given, for our typical example for this lecture, we're going to be doing bake that cake. We will be given specifications for what this bakery functions have to do. Maybe this could be a set of them. Must return a chocolate cake object, which we've seen, it does. But the cake must be capitalized and the cake price must be a number. For this, we created a list of specifications. And as developers, it is extremely important to do this, to create a list of everything our application should do and not do within reason, in order to make sure we maintain a list of those specifications and what our application should do in order to say that it works. So it's always great to keep a list about this, but it's also great to do by introducing a new way, or not a new way, but a way of developing your applications with unit testing. This thing is called TDD, Test-Driven Development, in which we are given a list of specifications. We write out those tests in unit testing in Jasmine, and then we write our application in order to do that, or to meet all of those test requirements. So it's a kind of a two-step process or a three-step process. You're given the list of specifications from your manager or whoever, or from launch code. You write those tests to check to see if your application will do it. Now, if you're asking yourself, well, if I haven't written the application like yet, won't it like not work at all? Yeah, it won't. But you'll have the specifications written and it will be failing. Yes, you're gonna get a lot of red, but once those tests are written, then it's time to start writing your application. That again is test-driven development, that TDD that we learned about in this reading. So what we have to do is create and follow those list of expectations. So let's go ahead and see how we do this with this kind of specs that I just came up with for birthday cake. So typically, if I was just starting out with this bakery application or this bakery function stuff, I wouldn't even have any of this written. I wouldn't even have the bakery here at all. So what I would do is actually just delete this because we're going to do this again with TDD in mind. So yes, I want to delete my bakery.js. So first things first, I'm going to write my it statements. So it should return a chocolate cake object. My next one, it says my cake name must be capitalized. It should capitalize the cake name. There we go. And then finally, it was the last one. The cake price must be a number. So should have a price as a number. There we go. So look at what I just did with TDD. I wrote out all of those, all those if statements right away, all under that one describe. Because again, our three things are right here. If we look at our if statements, has all those in there. But I haven't written any tests yet. I want to just first line them out. Now it's time. If I go ahead and just run this, we're just going to have fun. Take a look at it. It's going to give us a bunch of errors because bakery.js doesn't even exist. Again, because we deleted it. We haven't started writing our application. So once I'm in here, that's when I can start writing my code. So up here, we already created this code. So I'm just going to keep it there just for convenience. So we keep our actual and expected and we do this. We run it again. It's going to be a failure. Nothing's changed. We just pasted that code in there. We've written it before. Then we come down here, should capitalize our cake name. In here, what I want to do is I want to say const actual equals bakery. And what I want to do is check to see if this function capitalizes the word. So what I would type in here is a lowercase word. So I say chocolate cake or birthday cake. We'll just keep it birthday cake. It's good to keep our testing stuff basically consistent as we move forward. B-I-R-T-H-Day cake, just like that. And then we're not testing the price, so we can just say whatever we want, but I'll just keep 1099 in there, just again, keep that consistency. Then ask yourself, what is your expected? What are we testing? Are we testing the whole object? No, we're testing one part of the object. What are we testing? We're testing the name of the cake. We want to see if it's capitalized. So I want to see if birthday cake has a capital B. So I'm just capitalizing the first letter in this one. So I'm going to say lowercase cake. So our expected from this test is birthday cake with a capital B. So that's our expected now. And then we say expect our actual to equal our expected. There we go. And then finally, the price should be a number. Oh, why are you giving me that? Again, what we do is that we can actually just copy this up here. Our actual, just bring it down there to save us a little bit of time there. And we can keep that lowercase, that's completely fine. Because again, what are we checking? We're checking the number. We want to see if this is actually a number. So what I'm going to do is provide it a string. I'm going to provide it basically a negative case. So I'm going to say 1099 in a string. And our expected, constant expected, should be 1099. Just like that. And then we're going to copy this line because it's just repetitive here. So we copy that and we paste it down here. There we go. We have just written 3 tests for this. We have provided our actual, what function we need to call in order to test this thing that needs to test. And then we provide our expected. And then we actually grade our test here. So again, let's go ahead and run this and see what happens. Still looks like it's pretty broken. So this is the first step of TDD. You wrote all your tests first. Your application is not even started yet. That's fine. The next thing we need to do then is start making these tests a little bit more green. So that's what we're going to do now. Not in the spec here, we're gonna come down here and we're actually just press new file. That'd be way easier, right? New file. And what are we creating? We're creating the actual application to test. That one was bakery.js. Make sure that your bakery.js does not get stuck in the spec folder. That is not going to be helpful. So make sure you just drag it over here to our index. There we go. It's in the correct directory there. Remember, only spec files, only test files within the spec folder directory. Awesome. All right, now let's go ahead and start creating our function once again. So now if we come back up here to our bakery.spec, you don't have to be in the bakery.spec to run it. We click run, and we're now getting less failures because bakery.js does exist, but now we get 3 Fs. It's a lot of Fs there. But at least the tests are running. That's the next thing to check. Is my spec file actually working? In this case, it is. It's not working in my favor, but it is actually working. All right, so now it is time to go step by step through this in order to complete our TDD. So it should return a cake object. I see that as my first task, and that's what I'm going to want to do. I need it to be whatever in this bakery file. So I go over to bakery.js, and you've seen this, so it's going to be very quick. Function, bake that cake, cake name, cake price, open and close curly brackets there. We return open and close curly brackets to create an object. We say name, cake name, and then price, cake price. All right, so if I would have just said, I need to return a cake object. Typically in your specifications, you're gonna be like, you'll ask what it actually is a cake object. We just know this because our lecture example showed us what it is with the name and the price there. So that's where I got that from. And also we can see that from our expected as well. If the tests are written for you previously, hint, hint for assignment 3, check to see what their expected is, to see how you're supposed to be actually providing the return stuff for the function. All right, let's go ahead and run this. Let's see what we get. Oh no, what's going on? Oh, what am I missing? Come on, Kyle. I need to do a module.export. There we go. All right, let's run this again and see what happens. Guys, we're only down to 2 Fs. We're still failing, but only 2 times now. So there we go. What we did is that we just checked off one thing on our list of things to do. That right there is TDD at work. We have 1 less failing test. It's now time to get onto the second one. Let's go back to the spec file and see what that was. Should capitalize the cake name. Okay, in order to capitalize cake name, I need to have something in there, or I need to have something creating the cake object. Well, from our previous test, we already know that there's something creating that cake object. So what this just showed us is that, again, TDD builds upon itself. It starts the application. We get the basics of the application going, and then we're going to start adding things on in order to get these tests passing. So let's go ahead and do that. And come over to here to bakery.js. I'm going to do this fairly quick so we can keep this example in here, but this is how we would capitalize something. So what we do is we say const capital cake, well, capitalized cake. What we can do is say cake name dot, oh, I always forget, I think it's substring for full. I'm going to mic an error here, 01 to uppercase plus cake name dot substring. I think it's all lowercase. 1 for starting. There we go. Let's actually see what we get here. Oh, let's get to this. What I forgot is to put the capitalized cake inside the object that's returning. So let's go ahead and do that. So I changed from cake name now to capitalized cake. Let's see if it actually works. Oh, still failing. Let's go ahead and see what I actually am getting back. What we can do is actually use a console log. I don't think that is the correct one. Capitalized cake. Capitalized cake. There we go. Run that. Birthday cake. Oh my gosh. We are returning this. This is how TDD works. It's like, okay, shouldn't that be passing? Well, it looks like it is all capital. That's cool. But that means maybe, okay, so I checked this out. Birthday cake is with a capital B and lowercase c. That's cool. So it is capitalizing it properly. So I come back over to my test and it's saying, okay, in this function or this test right here, am I actually truly checking what it should? My expected is just the string birthday cake, but my actual is going to be an object. return from that function. Remember, bakery returns an object. So what should I actually be checking? Should be checking my actual data dot name. Name being the property inside that object. So I wasn't checking the name properly. And that's going to be the same for down here. Actual dot price. I need to actually get the price property out of there to check it against my expected, which is 10.99. So the one big thing to check is make sure your actual and expected are there. When it comes to TDD, yes, you're going to see back and forth, but there is that set way of creating the test first and then into there. Will some of your tests be written incorrectly? Yes, but that's why we explore those two sides to find those logical errors. So we're going to run this again and see what happens. There we go. We're now down to just one F. Awesome, awesome. I'm going to go hop back over here to the bakery.js and remove that console log because we have debugged that. Fantastic. All right. Last thing to do here is that what we need to do is come back over to our bakery. Oh, excuse me. We get the check mark now. Awesome. Check mark done. Last thing is cake price must be a number. Let's go ahead and do that. So it looks like in this one, we're passing in a string and then we are expecting a number back. So we want that test to pass. So we come over here to bakery.js. What we can do to make sure that a number is returned, as long as it's a valid string, is technically we can just wrap number around here if we wanted to, just to do it quick. We want to do something like that. Again, we're not protected against a lot of different cases, like if they pass in like undefined or something like that, but at least this is one way we can always convert it to a number in case it comes in as a string. Let's go and run this and see what happens. There we go. Once we wrap that in a number, we have cake price in there. We are getting 3 passing tests. If that's everything my specifications say, then that technically is showing that this application is working to how my user is wanting it to work or how my manager wants it to work. So right there is a very, very simplistic, straightforward, quick way of how TDD works from start to finish. But it is a good way just to get our feet wet in it as we move forward with unit testing into our assignment 3 and into the future of JavaScript and Java. Unit testing goes to every programming language. So at this case, I'm going to go ahead and unmute it. And any questions on what we just saw here?
I'm curious about line 2, like the cake name dot substring, the numbers inside of the parentheses. Are they like the number of the index of the C and the B for bake and cake, or?
Yeah, so this was I'm sorry that, I know we haven't talked about substring there. So this might be, we might have that knowledge gap right there. So what substring does is that it just takes, think of it as an array. You take a part of the array out and that's what you want. For substring, it's basically taking a part of that string out and taking it over to the side. 0 and 1 is taking from the 0th index to the first index, but it doesn't take actually the first index. So what that says is that I just want the first letter. So in this case, whatever the first letter is. So in birthday, it would be B. So that is what it's taking. And then we say to uppercase. So it turns it to uppercase. Next, we say cake name.substring 1. Where do you want it to start? I want to start at that first index that it stopped at, and then take everything else. If I don't provide a second argument in this one, it just takes everything else. So that'd be Earth Day cake, essentially is everything else. And then it has a plus there, it appends it together, and hence we are done with a capitalized cake.
Okay, that's cool. I was thinking that, but I didn't know if that was accurate, so I thought I'd ask.
Nope, all good. Amy, yes, we absolutely can show a negative test. One would be right here, where we are passing in what it shouldn't be and checking to see if it actually does the correct thing. So you can test like a negative case here. Negative cases are basically, if the world isn't perfect, which we all know it isn't, what would be things that your user could do to possibly mess up your application? This is one of them. Okay, I want you to always put a number in for this bakery thing. Well, my user is like, nah, not today, Kyle. And they pass in a string. We want to check to see if we are protected against that. So our expected is a number. So we check to see if we have converted that string, that negative case, passed it in and changed it back to a number. So this right here would be a negative case. A good example of a positive case is right up here. Did we check to see if everything just went A-okay according to plan? Did it just create the object? No questions asked. It sure did. If we wanted to get a little bit more into it, another negative case to expand on this, which testing, you can always find more and more negative cases to go into, should return a cake object when provided bad data. Something like that. And what we can do is say, okay, what if I say birthday cake with a lowercase b and 1099 is a string now? Well, I want to see if my object still comes back as birthday cake 1099. So I run this. And I see now I have 4 passing tests because it does protect against that bad data. So this negative test is testing to see if that negative, dirty information that the user provided is actually cleaned and provided back a better object. So Amy, does that kind of help?
Yes.
Awesome. And we're right on time, so I will take one more question. Or 2, or 3. I don't know. I feel charitable today. Nothing? Oh my gosh, come on. Someone give me any kind of question here. It is unit testing. If there are no questions and I find somebody who like does assignment 3, is like, I don't know how to do this, I'm gonna find you and help you.
Yeah.
All right.
I have a quick question.
All right, what's up?
Would I be able to see what's inside of index.js one more time?
Yeah, absolutely. So this is boilerplate code. You're gonna find this in all of the examples here tonight.
Okay, so that's just
exercises.
Jasmine. Okay.
Yeah, this is, again, boilerplate just means very repetitive code. You're going to see this in all your unit testing stuff. Do not touch it, please.
Can we see what's inside bakery? JS?
Yep. That is our bake the cake function here. We have that capitalized cake on the first and then returns those objects right there. Remember, we placed that capitalized cake in as this property's value, and then we wrapped this cake price in a number to protect us against any strings being passed in. Remember, if a number is passed into that number function, the number function is going to be like, what the heck? And just kick back the number. So we're all okay there.
I have a question.
Yeah, Christopher.
So I understand what expected does, but what exactly is the point of actual?
The point of actual is to actually have something to test. Remember, in our class example, you are going to take a test, whatever test that might be, a math test, an English test. You fill out that paper, that's you. That's your actual. You did the test. Your expected is the answer key, what your teacher has to check your answers against what you just did. That's your expected. Comparing the actual to the expected, that is the result of your test. Do you pass or fail? So the point of actual is to actually have something from reality to check against to see if your function's actually running.
Okay, thanks.
Absolutely.
I have a question.
Yeah.
Can you go back to the bakery.spec.js?
Yes, there we go.
For the negative test at the bottom, shouldn't it be to not be equal since it's a negative test?
So negative tests, depending on what we're talking about here, a negative case kind of test is to test to see if the values are, I mean, we can do it not equals. A negative case means a test that if the data is not good, depending on what the definition of what that was provided by the book, are negative cases to test what if the user gives you bad data. In this case, it is bad data. So a string was being passed in for a number. That's not what we wanted.
So you would expect it to not be equal, right?
We would expect them to be equal. I mean, what we could do is say, dot to, I forgot what, is it not equal? I forgot expected.
Not be equal, I think, or to not equal. I can't remember.
I actually forgot expected. I don't use Jasmine.
I think it's dot not.
I think
Dot
it's
to
dot
equal.
Is it
not.
dot not? Okay. I just want to, cool, thank you. Dot not dot to equal. So I mean, if we run this, we will get that it is a failure because they are not equal. Because 1099 and string and 1099 number are not equivalent. So what we would say, oh, go ahead.
Because you fixed the code on the bakery.js by putting a number outside of the, can you go back to that bakery.js? Because you put the number outside of cake price.
So remember, our specifications on this was that the cake price must always be a number.
Mm-hmm.
So in order for it to always be a number, we have to wrap that number in there with cake price.
Yeah, I get that, but
okay.
Had you not fixed that part, the test would have passed, right?
With this one, I believe so, but that would be a false positive. We are not actually testing what we want to test there. Let's see if it actually does it. So we need to test to see if we pass in a string, we get back a number. We can also check if we pass in a number, we get back a number. That's a typical case right there. That's a positive case. Excuse me, an ideal case. So with this one, yeah, we're still going to failure because technically the number in the string will still not be equal. So let me put that back. So what I'm trying to get at here is that a negative case does not always have to use not equal in it.
But you could have done it that way, right?
Technically, what you have to do is that you would say that I want it not to equal the string of 10.99. I do not want it to be a string. I want it to be a number. So technically, this is a way you could say it passes, but you're still not validating that that is a number. Remember, our specification says it must be a number. You're just checking, or if we did it this way, I'm just checking if it was not a string. So this test doesn't really validate that it's returning what it should.
Okay.
So we have to check to see if it actually is what the specifications exactly say. Is it a number? So we have to see, is it actually a number there? So I'm going to take out not real quick. That is what we're checking right there. So I know that's really confusing. This is like the testing logic, which I really am not a fan of. But it is kind of getting that mentality like, okay, I got to check to see if this thing is actually returning a number, even though it passed in a string. So we kind of just, yeah, that's how we validate that. I'm sorry if that wasn't the best explanation you were looking for. We can dive deeper into it outside of class if you'd like.
Okay. All right.
I have one last question.
Yeah, what's up?
So I know it's going back a couple chapters, but inside of Bakery.js, could you explain the substring for the to uppercase?
Yes, I can. I'll do it really quick. So it's also will be in the recording here for a more in-depth one because I got that question previously. But yeah, real quick. So substring 01 means I want the 0th index character and end at the first index of that string. So what that's going to get me back is the first character. So in birthday, that would be B. Then I say to uppercase, it's going to capitalize that B no matter what, plus cake name.substring 1. 1 is saying I want to start at the first index of that string, whatever cake name might be, and get everything else. We get everything else because the second argument is where it says stop. But if we don't provide it, it just gets everything anyway. So that's what substring does. It just grabs a part of the string for you.
Okay.
Kyle, super quick question.
All right, what's up?
Just for the Bakery JS one right there. Or not the Bakery JS. Anyway, so the actual, would that be like in any scenario like user input, like comparing user input to what we expect it to be?
It could be depending on what your function does, but if it's user or something like that, or anything that the function's doing, that is your actual.
Okay.
How you can tell your actual between your expected? Yeah, real quick. Actual between expected. Actual will typically be something returned from a function or something returned from some kind of process. Your expected is easily identifiable because it's hard-coded. Again, hard-coded means directly typed out letter by letter, character by character. That is hard-coded. So if you hear that term, that's what I am referring to. Well, great question. All right, everyone. Awesome questions tonight. Happy to see everyone's energy has not gone anywhere in the week that I've taken my hiatus. So fantastic. We are officially finished. So great job. There we go. So awesome.